a game still evolving to this day.
But what people don't know is the physics behind it.
Here we go!
Volleyball is a game played by many, and unless you're an avid researcher, many questions are raised when people watch it. Like, what positions are there? Why did this person do that? And the age-old question, why is there a person wearing a different colored jersey? As a volleyball player myself, I am no stranger to these questions, but unfortunately today, we won't be answering those questions. What we will be talking about is volleyball aerodynamics.
Volleyball is a game where the goal is to win a set amount of points before your opponent, like most sports, to win. The game is a non-contact sport where both sides, comprised of 6 players, are separated by a net. And the way to win points is to put the ball down and on the other side of the net, or to hold out until the other team fails to get the ball over or hits out.
Major question raised by people when watching volleyball is why people serve so different. The main serves are, in layman terms, the one where they toss the ball super high and slam it, and the other one where they stay low and hit it discreetly.
Most people think one serve is obviously better than the other, but each serve has its own strengths, and it all comes down to one thing: spin. The difference between this serve and this serve is how it's hit. One is hit in a way where there's no spin, and the other with much topspin added. But first, let's talk about something called the Bernoulli's principle.
Bernoulli's principle states that when an object travels through a fluid, in this case, air, when the velocity of the fluid increases, the pressure must decrease in an ideal environment. This concept is given by this equation.
When a ball, in this case, a volleyball, travels through the air particles are pushed around the ball, creating a pattern known as laminar flow. However, when the ball has spin, this air diagram changes. As the spinning ball experiences the same airflow, friction via the ball physically drives the air in the direction of the spin. On one side of the ball, air is pulled down, while on the other, air gets slowed. This difference in fluid speed causes a pressure difference, which by Bernoulli's principle causes a low pressure zone leading to the ball veering in that direction.
It's actually up.
That direction!
And since the ball applies a force on the air which pulls it down, Newton's third law states that the air must pull the ball up to provide an equal and opposite force, causing the ball to experience a veering known as the Magnus effect. The Magnus effect isn't completely visible to the plane observer, as the mass of the ball usually limits how accelerating this Magnus force on the ball can be. However, with a cylinder of paper, the effects of the Magnus effect are much more obvious.
The Magnus effect is cool and all, but what's also interesting is when a ball has no spin. In volleyball, the general term for a serve like this is a float serve. Because similar to a knuckleball in baseball, a volleyball with no spin appears to move randomly and sporadically in the air while not dropping.
How does a ball float? It has to do with the divots on the ball itself. They're either seams or textures on the ball. When a ball moves at a considerable speed through the air, these seams and divots cause turbulence and bump the air traveling onto the ball up and off of the ball, causing the air to travel a greater distance off one side of the ball. Due to Bernoulli's principle, there will be a pressure difference on the turbulent side of the ball because of the greater velocity of the air moving on that side, causing the ball to shift towards the area of low pressure. This causes the ball to move sporadically through the air as the divots are hit randomly and differently as the ball travels through the air.
As you can see, these two types of serves have their own strengths and weaknesses, which is why players of volleyball choose different serves to go for. In order to add the most power to the ball, players always go for the top spin serve because the flight of a ball can be seen as projectile motion, where the ball must fly over the net to the other side and in. Since humans can only jump so high for a serve, they must rely on forces to guide the ball down in a parabolic path to get it in. The force of gravity can only go so far, so the Magnus force from spin can help servers add more horizontal force as they serve because the ball will fall down sooner.
As for the float serve, it's a way to apply a safer amount of power while still causing trouble for the other team due to the unpredictability of the ball's flight path.
I hope this video on volleyball serve physics brings a little science
And spice!
into your everyday life. Hope you
learned
learned something new! Oh.